forward, the liver also plays a role of detoxification. Remember, when we were looking at the structure, we've noted that as blood flows through the sinusoids, there are phagocytic cells called Kupffer cells that remove and destroy foreign particles, toxic particles like the bacteria and others, because we've called them phagocytes or phagocytic macrophages. So to detoxify is to remove toxins, poisons from blood. So all those poisons, drugs and others, are removed from the blood by a process called detoxification by that organ called the liver. Remember, in deamination, we saw that when the amino group is removed, it forms urea, which urea is toxic. Therefore, the liver further converts it to a less toxic compound called urea that is removed from the body. Still a process of detoxification. Meaning detoxification generally is carried out by the liver and those other cells that we've called the Kupffer cells. The liver also inactivates hormones and eliminates sex hormones. Now, hormones, after being discharged into the blood and exerting their effect on the target organs, these hormones, if they remain in blood, they would continue exerting that effect on the target organ. But remember, we talked of the feedback loop, meaning these hormones, after exerting their effect, then they are broken down or they are inactivated. So that inactivation is done by the liver. The liver also eliminates sex hormones. After the sex hormones have performed their role, they don't remain in blood for long. They are immediately broken down and then sent to the kidney where or for excretion, or at times they are expelled within what we've called bile. The other role of the liver is production of bile. We've already seen that bile is manufactured or secreted by the hepatocytes, but into the bile canaliculi, which bile canaliculi then transport the bile to the gallbladder, where it is temporarily stored and then later released to the duodenum through the bile duct under the influence of that hormone, remember in nutrition, called cholecystokinin, also called pancreazymin. Cholecystokinin or pancreazymin are hormones, or it's a hormone responsible for the release or discharge of bile from the gallbladder where it is stored into the duodenum to bring about digestion. Then the liver also plays a role in breakdown of the red blood cells. Breakdown of red blood cells. How does this occur? In the fetus, red blood cells are manufactured in the liver, you remember? But in adults, the liver now turns around and instead breaks down those worn out red blood cells. Remember, red blood cells have a short lifespan of only 3 months because they lack a nucleus. Since they have no nucleus, they have a short lifespan, 3 months or 120 days. 4 months, that's about 120 days. Now, at the time when they are to be broken down, Kupffer cells, the phagocytic macrophages of the liver, now come into action. They break down these liver cells, these worn out red blood cells. But where do we find the Kupffer cells? In the sinusoids. Remember the sinusoids? So that's where we have the Kupffer cells playing a role of phagocytosis, breaking down the red blood cells. How does this occur? Remember, the red blood cells contain hemoglobin. Now this hemoglobin in the red blood cells gets broken down into heme and globin. Hemoglobin broken down into heme and globin. But remember that heme is iron, while globin, that is the protein part. Therefore, when hemoglobin is broken down into heme and globin, what happens to the globin? Globin is the protein part, which proteins are made of amino acids. Therefore, the globin, the protein globin, is broken down into its constituent amino acids that are then utilized by the body. While the heme group, which is containing iron, iron is now removed from the heme group. When removed from the heme group, will now remain with the part of iron and the remaining part which does not have iron. So the remaining part without iron forms a pigment called biliverdin. Biliverdin, that is then converted into bilirubin. Bilirubin is a component of bile. Remember, we've seen that the liver manufactures bile. But how is this bile manufactured? And what are the components of bile? I repeat, we've said, in breaking down the worn out red blood cells, the hemoglobin within is split, broken down into heme and globin. Heme is the iron part, globin the protein part. What happens to the globin? Globin, being protein, is broken down into its constituent amino acids that are utilized by the body. How about the heme part containing iron? Now the heme part is split into the iron component and the non-iron, the remaining part. Now the remaining part, which has lost the iron, forms a pigment called biliverdin. Biliverdin is converted into bilirubin, which is a component of bile. Therefore, what does bile contain? It contains bilirubin, formed from biliverdin. Biliverdin is formed as a result of heme, the iron part being removed from heme. So the remaining part is what we're calling biliverdin. Now what happens to the iron part? The iron, after being removed from the heme, combines with a plasma protein. There are plasma proteins in blood. Now the iron will not be lost. The iron remains in the body. Therefore, it combines with the plasma protein to form a complex called transferrin. Transferrin. Meaning, what products are we getting? Transferrin, the iron part that remains in the body. Then bilirubin. Bilirubin, formed from biliverdin, which is a component of bile, and the constituent amino acids from the breakdown of the globin, which is a protein. Moving on, the liver also stores blood. The veins within the liver can expand and contract. When they expand, it enables the liver to store large volumes of blood. Therefore, the liver functioning as a reservoir of blood. Along with the spleen, they regulate the amount of blood within the body. The liver also stores vitamins. Remember, we have the fat-soluble vitamins and the water-soluble, but it stores the fat-soluble, that is ADEK, vitamin A, D, E, and K. But it also stores some water-soluble, like vitamin B12. It also stores minerals, the copper, zinc, cobalt, iron, potassium, molybdenum, etc. Production of heat, because it is the major metabolic center within the body. That heat is important in regulation of body temperature. Lastly, how is the structure of the liver related to its functions? We have seen the structure, we have seen the function. In other words, what are the adaptations of the liver? We've seen that it has the Kupffer cells, phagocytic, that ingest the bacteria, the worn out red blood cells, and so on. Then the hepatocytes, the liver cells, are closeness of hepatocytes with the sinusoids and the canaliculi. Hepatocytes being close to the sinusoids, remember in the sinusoids there is flow of blood, therefore exchange of materials, remove nutrients, remove oxygen, add wastes. Hepatocytes are also close to the canaliculi, thereby leading to formation of bile, so that it is released into the bile canaliculi. The liver has an excellent supply of blood. Remember, it is supplied by the hepatic artery and the hepatic portal vein. The hepatocytes have numerous mitochondria for generation of much ATP, which facilitates metabolism in the liver. Hepatocytes in contact with blood vessels. Remember, in the sinusoids, we say they have numerous microvilli to increase the surface area of exchange of materials. The liver being large, the largest organ, provides a large surface area for metabolic reactions to take place. It has numerous peroxisomes with catalase and other oxidative enzymes, but we said this catalase is important in breaking down the hydrogen peroxide, which would be poisonous. Liver tissue being elastic, the veins within can expand and contract to store large volumes of blood. And lastly, hepatocytes having or being undifferentiated, enabling it to perform a variety of functions. Liver disorders of the liver. One of the liver disorders is hepatitis. This was a common disease, which is basically inflammation caused by viruses. Hepatitis viruses, A, B, C, D, and E. There is another liver disorder called jaundice. Jaundice bringing about yellowing, characterized by yellowing of the eyes and lightly pigmented skin. Then there is another disorder called cirrhosis, whereby the liver becomes fatty, fibrous. This is common in people who take a lot of alcohol. Then liver cancer. Cancer is due to exposure to chemicals, carcinogenic chemicals, and other chemicals within cigarette, the smoke, the radiations, and so on. So those are the disorders of the liver. So when we meet again, we shall move to another homeostatic organ, and that is the pancreas. Until then, I wish you all the best. Stay safe. Bye-bye.